So let's start again. So this, you see here, I was talking about this cooling here. So this cooling is mainly from the aerosols. You remember the first lecture? I told you if you have aerosols, you have a cooling, you see? So that's why it's mainly from the sulfur dioxide. So it's an aerosol. It makes a cooling of the, this is why we have this cooling here. But if you make the total, so you will have at 1.1. So if someone asks you, what is the warming? We are at 1.1, okay? You remember, a lot of people, a lot of countries say, we will try to limit, it's the Paris Agreement. You know the Paris Agreement? Paris Agreement, a lot of countries say, okay, we will try to limit the warming between 1.5 and 2. So they make this in Paris, they call it the Paris Agreement. But you will see that, just to tell you that this year is the first year where we are sure we will, for the first time, have 1.5 degree warming. So it's from Copernicus, it's a European project. And we compute all the, and this year, it's really unique, the first year where we reach 1.5. In fact, 1.5, it's in the Paris Agreement, we say, okay, we will reach 1.5, but at a mean. But this year is the first year where we will, so that's why it will be very difficult to limit the warming to 1.5, or because already this year is the first year where we'll have 1.5. So just remember, we are at 1.1 degree warming. So this is what I said. So the recent change in the climate are widespread, rapid, and intensifying, and unprecedented in thousands of years. I show you the picture. And the global warming over the past 10 years, yes, was about 1.1 if we compare to this period. So what is also a key message for this report is that unless there are immediate, rapid, and large-scale reduction in greenhouse gas emission, limiting warming to 1.5 will be beyond reach. And I told you, this year, it will be the first year, global mean 1.5. I think it will be in the news, but maybe in January or, well, so, yes, so the CO2 concentration, as I put here, in 2019 were higher than at any time in the last 2 million years, and concentration of methane and nitrous oxide were at their highest in at least 800. You see that we are really breaking a record for this. So also one thing for this report is that it's for the extremes event. It is indisputable that human activities are causing climate change, making extreme climate events, including heat waves, heavy rainfall, and drought more frequent and severe. So it's really clear. So in this report, some new mathematical method has been used we call this detection and attribution. So there is an event you detect, and then you attribute the event. Is it due to climate change, or is it due to natural, I told you, variability? So what is the percentage of climate change in this? And in this report, we found that climate change is really impacting the extreme event, and it is really very clear that climate change is making these extremes more frequent and severe. So including heat wave, and you will see in the next slide. So this is also very, we need to make this into our mind, is that climate change is already affecting every region on Earth in multiple areas. So there is no region which says, okay, I am safe from climate change. So there is no region in the world. So every region is affected by climate change. And the change we experience will increase with further warming. So every 0.5 degree warming will intensify all this change that I just said. This is about the extreme precipitation. So since 1950, heavy rainfall events have become more frequent and intense over most land area where there is sufficient data, of course. And human-induced climate change is also contributing to this increase in drought in some regions. But we will see this in the map very clear. Yes, this is very important also. Okay, we said, okay, we would like to limit the warming, but there is some parameter which will never go back. Even if we limit the warming, this parameter will still see change. And these are all related to the ocean, for example, ice sheet, sea level. So these parameters, because they are slow parameters, even if we stop the emission now, these will still keep going, keep going for thousands of years. Because this we call the slow response system. In the climate system, you have a slow response and you have quicker, but this is the slow response. So they will not be, they will still be, so they will not be stopped by limiting the warming. But we can have reduced the warming in some. Yeah, this is also very nice. So it will give you an order of magnitude. So suppose that we are here, okay? And you know the IPCC use scenario in the future, some projection, okay? So we have either we say, okay, we keep, this is the high emission. So it means that we will not do a lot of mitigation. We will just emit as we are doing now, okay? So we call this the high emission. There is another one, highest, but this is high. And then we have the low emission here. You see that we will succeed to reduce the emission. This morning we heard about net zero. So India is committed to have the net zero, I think, around 2070 or 60. 70, I think. 70, yes, 70. China is 2060, I think. And then in Europe, they are focusing on 2050, I think, 22 net zero. So okay, so these are the two scenarios that we will take, and this is the emission, okay, from the ground, emission. So now we are here. So how many years we need to see if we follow this, if we reduce the emission following this scenario, how many years we need to wait until we see the impact on the concentration in the air? Okay, so we have the emission from the ground, from industry. So how many years, we say, okay, we will reduce. How many years we need to wait until we see the impact on the concentration, on the air? This is here, so you need between 5 to 10 years. So if you reduce now, you need between 5 to 10 years to see the impact on the air. Okay, so it takes time. Now, how many years you need to see the impact on the surface temperature? I told you, we are at 1.1. So how many years we need to see the impact? You see, we are here. So we need between 20 to 30 years reduction. So that's why I told you this Paris Agreement limiting between 1.5 and 2 is really beyond reach. Because even if you stop now, you need between 20 to 30 years to see the impact for the temperature. This is only for the temperature, but for the sea level rise, it will still keep growing, increasing, because it's a slow process in the climate system. Okay. So, to limit global warming, strong, rapid, and sustained reduction in CO2, methane, and other greenhouse gas are necessary. This would not only reduce the consequence of climate change, but also improve air quality. I will talk about this. So, while CO2 is the dominant greenhouse gas and reaching net zero CO2 is required to limit global warming, strong reduction in other greenhouse gas emissions are needed. And I told you about the methane. The methane is also now very focused. In Europe, we are also focusing on reducing methane because in 10 years you see the effect. It's not like CO2. This, I think, no, it has not been shown this morning. But this is the same like what Subimal showed this morning, but this is about hot extremes. So these are the observed, so what is this? Yes, the observed change in hot extremes. So we take the hot extremes in the world. So this is Europe. We are here, India. So this is the South Asia. So India is part of here. And you can recognize this is America, South America. This is Africa. Okay. So we are here, and this is the change. It's observation. Observation. So if it is red, means an increase. So we have an increase in the type in hot extremes. So we have an increase in hot extremes in India here. And what does mean this tree? This means that we are high confidence that is due to human contribution. So human contribution is, we are highly confident that this increase in hot extremes in India, for example here, is due to human influence. So this, you showed this morning, Subimal showed this. This is for precipitation, the same here. So we have an increase of heavy precipitation, but as Subimal explained this morning, this is due to limited agreement. So what does mean limited agreement? He explained this very well this morning, but it's just that you have some local effect, maybe some which drive the trend in another direction. You have global effect so you have some difference, and you don't have this, all the papers don't converge to the same conclusion. So you have limited. We say this limited agreement. So we don't have an agreement on the type of change because of monsoon, because of large-scale phenomena, local-scale phenomena, urbanization also enter here. So that's why we have limited agreement on the type of change. We have the same. If you see Europe here, Western Europe, we have the same aspect because we have also some large-scale phenomena and local-scale going also. Yeah. So we don't have we have limited agreement. So yes, I told you about the scenario, future emission. So future emission will cause additional warming with total warming dominated by past and future CO2 because it's not only future CO2, it's also the past. So all the emission, historical emission, and this is mainly by US and Europe that contribute a lot to this. You have the historical emission, which is also very important to take into account. So here you have we call this SSP, so socio-economic, I think, scenario also here. And you have this 8.5, 7, 4.5, 2, and 1. This means it's in terms of radiative forcing. We call this the radiative forcing, how much in watt per meter square of radiative forcing for it. So this is really the highest one, is business as usual. You see, we are here and we go to 2100. So we don't do anything, you see. So we will follow this path. And I can tell you that until now, we are really following this path. So if we, yes?
Sir, this year, 2024 and even 2023, have seen a lot of extreme events in Europe, particularly in Europe, like drying of Rhine River, and Danube River was also a little bit dry.
Yes.
It was very difficult to navigate there.
Yes.
So, do you think it was due to anthropogenic regions or due to lack of agreement, those things are coming?
Yes, so we make this. So first, I will answer in two ways. So the first one is that, for example, in Belgium, we had also in 2021 heavy summer precipitation. We have a flooding in Wallonia, so we have a lot of even death. I think 10 people dead, and we have a lot of cars, etc. So it's a flooding. So we made an attribution study. So it's a statistical study. We wanted to know how much of climate change contribute to this event. We found that it was not that much. We found only 18% due to climate change. So it's not purely due to climate change, this extreme. I don't know about the new one, for example, for Spain. There is a new one, flooding in Spain last 2 months. They are now making the study to see how much of climate change is affecting, is contributing to this extreme event. So it's still undergoing. So I don't know how much. The other thing is that we found that over Europe, the internal variability is still impacting a lot until 2050. So the extreme event will still be impacted also by the internal variability still. So we cannot see that it's really due to climate change, the extremes that, but I think I have some slide of this, yes. Thank you. So voila, so these are the scenario, the business as usual, and this one is a really optimistic one, but I think, yeah, it's really very optimistic. So as I said, we are for the moment following this path. So if you put the observation here, we are really following this path. Okay, so now I told you in the first lecture, we built the global climate model, we put all the process, and then was the question, we run for 100 years, and we see what is the new radiative equilibrium of the Earth. So if you run with this scenario, you will see that the new radiative equilibrium, it will be 1 here, maybe 1.5. This one, you go to this level, SSP2 here, 3, and okay, the SSP5 is the most, you see, we are more than 4.5 maybe warming. So depending on you have different sensitivity. This is what I show you in the first lecture. Okay, so now let's see how it impacts, see this on a map. So what you can see here is that with every increment of global warming, change gets larger in regional mean temperature, precipitation, and soil moisture. So this is for temperature. So observe a change if we reach 1 global warming. So if we reach, now we are at 1.1, so we already are beyond 1. So this is the simulated, and this is the observed. Okay? And this is if we reach 1.5, if we reach 2 degrees, and if we reach 4 degrees. Yeah, it's This is how it will behave. So India is here, you see, so it will be really a difference between 1.5 and 2 and 4 also. But I have a question for you. So tell me, why here we have in the north, we have higher warming than in the other part? Yes, it's the feedback. I told you about the feedback in the first lecture. We have the feedback with the ice. So all this is the glaciers. You have some, so if you have warming, you have glaciers will melt, you have permafrost, etc. will melt, and this will, yes, and then it's a feedback. It will make your temperature more warm, okay? And then again, more warm, more melting, and okay? So this is happening in this region because of this feedback that I show you. So the feedback is, that's why the feedback is very, very important, okay? So this is for precipitation. So this is the simulated change at 1.5. So we can focus on India here. How the precipitation. So it will be a little bit from 0 to 10 here. So we don't see a big change. The same here for 2-degree warming and here of 4. So we see all this region here having more precipitation at 4. But what is very hot is if you look to the Mediterranean basin here, that's really a hot area. So this will experience a big problem of drying and hot temperature and less precipitation. You can see here, if you focus, the basin, the Mediterranean basin from the north and the south will really suffer a lot from this, from the impact of climate change. So this is for soil moisture, yes, the soil, so everything related to agriculture is very important to know, because if you have soil moisture less, you need irrigation, you need to irrigate, and some land, you don't have easily the water. So it's really very important to know. So again, the Mediterranean basin, you see, it will suffer a lot here. India, here we still have like a wetting, so it will have a wetting of the soil. So with respect to agriculture here, you see that we have a wetting. But if you look to other area, Mediterranean, South Africa also here, you see that it will suffer also from a drought. So now let's talk about the extremes, okay? So the projected change in extremes are larger in frequency and intensity with every additional increment of global warming. So I told you that global climate change is making the extreme more frequent and more intense, okay? So let's look here. So if we reach 1.2 degrees, so I told you we are at 1.1, okay? So 1.2, these are the future global warming level here, 1.5 to 4. Yeah, here 1.5. If we reach 1.5, 2 degrees and 4, and these are the extreme. So the extreme, for example, let's take the 4 degree global warming. If we reach 4 degrees, you will see that the extreme will likely occur 9.5 times here. And it will make the intensity 5.1 hotter. So it means that this is the frequency of heat wave, for example, will be 9 times more frequent and 5 degrees more extreme. So you can see here for the other, this is for the 10-year event. So it's an event with return period. You know about the return period, right? So how the extreme, we compute the return period of the extreme, and here we compute for 10 years, so, and here for 50 years, the return period. You see here that the extreme of the extreme, let's say, so it's really the very extreme will be 39 times more. So the extreme of the extreme will more frequently, will happen more frequently. So here the same for precipitation, the same here. So how the frequency and also the intensity of the extreme precipitation over land, and this is also for the drying region. So this you can read. I will not. Very important things that I told you in this report is that we use global climate model, but we use also regional climate models. I will tell you, and this is really new for this assessment report, 6 assessment report, is that the IPCC make an interactive atlas. So you can go to this page web page. I can send you and then you can select. So it's all over the Earth here. You can either compute a map over all, or you can just select here, for example, over India. You can select this region, and then you can see the temperature, precipitation only over this region, only over India. But this is, for example, the mean temperature change at 2 degree warming. So if we reach 2 degree warming, what will be the temperature change here? This is the website I told you here, Interactive Atlas. So you can go to this website, and then you can select, you can see the temperature, the precipitation, how it will change for India, for example, or for your regions. Because this is the new in this report, is that we have also regional information, so high resolution. Okay. So let's have a focus on India here. So I go to this interactive atlas, and then I select only this region to show you what will happen here over India. So here, what I put here is this is the annual mean temperature. So the temperature mean, annual mean, and this is at warming of 1.5, 2 degree, and 4 degree warming. You see how the temperature will change. This is the total precipitation during winter, DGF, December, January, February. So this is the total precipitation and how it will change. This is the precipitation summer precipitation for different warming. And this is very important, is the maximum number of days, where you have the temperature maximum during the day over than 35. So if you have over than 35 degree, you will see that for India, very clear, that it will impact a lot here India, the temperature, the maximum temperature in the future. So it will really, here you can see it's even over India. If we look to the precipitation here, for example, you can see for the winter, so there will be a little bit of decrease here, of a little bit, but maybe it's not significant. But here it's significant. All this is significant. And then a little bit of increase here if we reach 4 degree warming. But for the temperature is overall warming here, you see. But if you, for 4 degree warming, you see that the north is warmer than the south here. But this is due to this feedback that I told you. Okay. So here, everything related to human is really very important. So urban, because you need to add to this the fact that you have cities. So if you are in the cities, but this we will see tomorrow, the lecture on urban heat island, because in city, so this degree here, so you need to add on a mean 2 to 3 degree of urban heat island. And urban heat island is not CO2, is not greenhouse gas. This is not related to greenhouse gas. Urban heat island is related to city. It's how do you build, we will see tomorrow this. So you need to add, and how this interacts, how climate change interacts with urban heat island. So this interaction, maybe it will increase or decrease. So this we will see tomorrow. So you need to take this into account.
So for India, if you see for the change in temperature,
yes, here.
It's not that drastic as the northern portion. It is rather smooth, and for number of days over 35, we already have very harsh summers.
Yes.
So is that really a change? Yes, that is a change. Maybe the number of days are going to extend. We are getting wetter in the summers, and that might cause urban floods. But temperature-wise, we are still at a better position, and why is that?
So why here we have the more
For the first case.
Here the temperature.
Compared to the north.
Yes, I can, yes. So this is the
temperature is not that drastic.
yes.
Number of days over 35 is increasing.
It's increasing.
We already have those.
Yes,
So,
yes.
the only thing that I see is the precipitation is changing drastically
Yes.
when compared to the rest of the world.
Yes.
Why is the temperature not increasing that much?
Here.
But the precipitation is increasing.
Yes, because here you have this, you can have also interaction to a large scale. You have the monsoon also, which impact this. I am not expert on the India climate, but I can imagine that you have different interaction. You have the monsoon effect. But for your question, why here it's not clear, and while here it's clear, because the change, this is the change on the mean, and we know that to change on the mean is different from the change in the extreme. This is the change of the extreme. The change of the extreme, because this is, we can call it extreme, is the number of days over a threshold. So this is much more higher than the change on the mean. So that's clear that, for example, even in the last period, we saw that, for example, in my country, in Belgium, we computed the change of temperature in the max, and the change of the the change of the summer, the change, so the Tmax, so the maximum temperature during the day. Okay, we compute how this changed, and then we compute how the maximum of this changed, like heat wave, and we found that the maximum, so the heat wave, the intensity changed much more, increased much more than the mean. So climate change is impacting the mean less than impacting the extreme. So that's why here we see the impact much more clear on the maximum temperature. Yes.
I would like to add. Just add this.
Yes.
Then why do we see drastic change in precipitation or the wetness?
Here.
Yes. We do not see that much change in the temperature, but a drastic, even for the world map.
Yes.
On the top.
Yes, because the change, the temperature is a smooth parameter, while the precipitation is very local. So that's why you see here, for example, you can see you don't see, you see some difference here, even for India here, some difference for but here you don't see it because the precipitation can be very local, the impact. While the temperature is more like homogeneous. Of course, if you go to deeper details, you will see the difference of city, lakes, but this is done by, I think, global climate model. This is global climate, so 100 kilometer resolution. So you see. So, but I am not expert on India climate. So, yeah, please.
Actually, monsoon is a global. It is affected by the global phenomena. It is related to Pacific oceans and southern temperatures and moisture availability.
Yes.
While the temperature is the local, means the amount of insolation is based on India's. The amount of insolation is coming from sun, so it is dedicated to India only. But for monsoon, the phenomena is being affected by the situation in Pacific, situation in South Indian Ocean. So that's why changes are different.
You have large-scale circulation, yes, which impact, yes.
So equalizer effect of the oceans has the effect on the temperature, because wherever the ocean will be there, due to ocean current, temperature will be all over, normal temperature will be there. You can see the coastal area, most of the land masses, it is almost
Yeah, here.
in the temperature.
So temperature, yes.
It is almost similar in all the coastal.
Yes.
Which are facing to the ocean.
Because it's impacting a lot the coastal, what happening in the coast, yes.
But Gulf does not have the same effect. It has a harsher effect. Gulf. It is on the same latitude, but it has a harsher effect. Yes, the Gulf region. It is in the same latitude, but it is a harsher effect. India and that
Here.
part of Japan has a better effect according
It
to
is already desert area. No, that is already desert area. Those of African part.
And just to tell you that this is a mean over 30 global climate model. So it's not only one model, it's a mean. So, yeah. Okay? So now let's see the change in the Asian monsoon. So what we found is that the South and Southeast Asian monsoon has weakened in the second half of the 20th century. This is with high confidence. And the dominant cause of this observed decrease of the South and Southeast Asian monsoon precipitation since mid-20th century is anthropogenic aerosol forcing. So due to this aerosol forcing, you see that we found, it was observed that the monsoon has weakened. You see again the aerosols, how it can impact the climate system. So the dry north and wet south pattern of East Asian summer monsoon precipitation change result from the combined effect of greenhouse gas and aerosols. So this is with high confidence. And in the near term, South and Southeast Asian monsoon and East Asian summer monsoon precipitation change will be dominated by the effect of internal variability. So this is with medium confidence. You see again that in the near term, the effect, this is what we saw also for Europe, that the internal variability will still be the dominant factor. So the climate change will not be seen until more beyond 2050 that we will see the impact. So until 2050, still the internal variability will impact a lot the precipitation and also here the monsoon. So in the long term, South and Southeast Asian monsoon and East Asian summer monsoon precipitation will increase. But this is with the medium confidence. We found also that the urbanization, I told you this, urbanization in India has impacted. So I found some papers where they found urbanization has impacted the monsoon precipitation also. But it was with medium confidence because I did not find a lot of papers that converge to the same, so limited agreement. So this is the region that, I show you here. So South Asia here, heat wave and humid heat stress will be more intense and frequent during the 21st century, medium confidence. So heat wave, this I told you, over the region here. Both annual and summer monsoon precipitation will increase during the 21st century with enhanced interannual variability. So, but let's keep in mind that this is really will be an important issue here, this heat wave and humid heat stress, because you combine temperature and humidity. I selected here this is from working group 2. Working group 2, I just select this because there has been some city here in India. So what is this? This is a key risk and adaptation option in selected cities across Asia. So let's focus on South Asia here, Ahmedabad and Mumbai here. You see that for urban heat island, for example, the key risk, urban heat and urban heat island is, what is this? This is the risk level, large, okay, and the risk evidence. If it's this color, it's high. So it's high risk level of urban heat in Ahmedabad. Mumbai, I don't know why they put here, I don't know. Maybe less research paper or, But here it's really very clear. You see that Ahmedabad will be important risk. Let's see, they also make the progress. What is the progress? Is the progress level, is it high, medium, low, and the progress evidence? So how the institutions are taking this into account? Institutional, infrastructure, ecosystem-based, and behavioral, also people. You see that if we look to the Ahmedabad also here, you see that the progress is quite high. So there is a quite high progress in this city concerning the urban heat island. So they are taking some measures and they are taking this into account. Voilà, so this is, I just select this from the working group 2. So just to finish, just to tell you, what is this? So this is the cumulative CO2 in gigaton, okay? And this is the warming. So how much of, if you put more CO2, how much of warming you will get? So this is the historical global warming. I told you we are at 1.1, we are here, okay? 1.1, and this is the relationships between CO2. It's more or less linear. You can say it's more or less linear relationship. So the more you add CO2, the more you will get temperature. So now let's count how much, so with current emission, how much we emit per year, global, we emit 40 gigaton globally. The Earth emits 40 gigaton per year. And so, and accounting for land and ocean carbon sink. Because there is also sink from land and carbon, forest sink. There is a carbon sink for forest, for example. And the ocean is also absorbing the. So taking this into account, we are emitting 40 gigaton. So this amount would be reached in a matter of decade because per year, so 40 per year. So let's see, what is here? Each gigaton accumulated atmosphere cause. So this is each 1,000 gigaton accumulated cause this increase. And so if we, just to tell you that with this warming, I think it's here. Yes, it's here, yes. So we are emitting 40 gigaton per year, okay? 40 gigaton. So this is the historical budget that has been, okay? So the remaining budget, how much of budget we still can emit if we would like to limit to 1.5 and 2, okay? So if we would like to limit to 1.5, we need to, this is the budget that we have. We need to emit less than 400 gigaton. So 400 gigaton, every year we emit 40, so it means 10 years. In 10 years, we finish this budget for 1.5. So now if we limit to 2 degrees, so it's 1,150. So you see that it's a matter of decade to reach this carbon. So just to tell you, we are at 1.1 degree warming. This year is the first year where we observe 1.5 globally. And if we would like to limit to 1.5, the 1.5 is mean on an average of 20 years, or we need to limit to 400 gigaton. So it's a matter of decade to reach this. Voilà, that's it. Thank you very much. So just to say that tomorrow we will focus, make a zoom on urban area. So this is just to give you a large-scale view. First, what is global model? Second, what is the state of the climate? And tomorrow we will focus on cities. And we will see the interaction with the urban heat island.
So any doubts or questions? In between, might have asked.
Yeah, and I am sorry if I could not answer to all your questions, because as I said in the beginning, I am not expert on all. So I am just adding a little bit on the interaction. So why I was selected, it was for the urban climate. So I contributed this report in the chapter 10. I contributed to the observation, and I contributed to the urban heat island and interaction with climate change. So how to provide urban heat island phenomena. So it's really, you cannot be expert on all this, it's impossible. So but yeah.